first section of chapter 3, linear equation and graphing lines, section 3.1, linear equations in two variables. An equation in two variables, x and y, is called a linear equation and can be written in this form: ax plus by equals c. A, b, and c are real numbers, and both a and b cannot be zero. If we look at the equation 2x minus 7y equals 1, this is a linear equation in the two variables x and y. If we look at the linear equation 3q plus p equal 5, this is a linear equation in pq. Our first topic is we will be looking at the solutions to linear equations in two variables. And a solution to any linear equations in two variables is one which each variable x and y, x is the first coordinate, y is the second coordinate, which when substituted, it makes the equation true. So that's our objective, is to substitute the numbers and make the equation true. This is an ordered pair, x and y. Remember, x is always the first coordinate in the ordered pair, and y is always the second coordinate in the ordered pair. Let's look at the first example. Identify whether the given ordered pair is a solution to the indicated equation. You can pause here and do the substitution and to determine if the ordered pair makes the equation true. A, the ordered pair is 3, 1. Again, remember, x corresponds to the 3 because it's the first coordinate. Y corresponds to the 1 because it's the second coordinate. So that's the ordered pair 3, 1. So let's determine if it is a solution. And basically you substitute 2 times 3 minus 1, x is 1. Does that equal, I'm going to put a question mark beside it because we want to know, does that equal 4? This becomes 6 minus 1 equals 4. And we know that 5 does not equal 4. So the ordered pair 3, 1 is not a solution to the equation 2x minus y equals 4. If we look at C, the ordered pair is 2, 5. Again, the x coordinate is 2, the y coordinate is 5. If we do the substitution, we have 3 times 2 minus 5. Again, I'm going to put a question mark because we're checking it. Does that equal 1? So we have 6 minus 5 equals 1. And 1 does equal 1. So that means that 2, 5 is yes. It is a solution to the equation 3x minus y equals 1. Let's look at section 3.1.2, completing the table of values. Completing the table of values. Linear equations in two variables have several solutions. These solutions can be attained by substituting any value for one variable into the equation and then solving for the value of the other variable. And our only variables are x and y. Let's look at the first one. For the equation 2x plus 5y minus 3 equals 0, find the missing number in the ordered pair so that it is a solution. And remember, a solution makes the equation true. In this ordered pair, x is -3, and we're going to look for y. And I will go to the whiteboard to solve that. So we have the equation 2x plus 5y minus 3 equals 0. Find the missing number of the ordered pair, -3. We don't know what y is, so that it is a solution. Basically, it's substituting. Remember, this is the first coordinate is always x, and the second coordinate is always y. So if we substitute here, we have 2 times -3, making sure you put this -3 in parentheses, plus 5y. And we don't know what y is because that's what we're trying to solve for here. Minus 3 equals 0. 2 times -3 is -6 plus 5y minus 3 equals 0. We're solving this linear equation for y. Combining our like terms here, -3 and -6, it becomes -9 plus 5y equals 0. If we add 9 to both sides, this becomes 5y equals 9. And if we have the equation 5y equals 9, solving for y, we're dividing by the coefficient. When we divide by the coefficient, y equals 9/5. So the coordinate that makes this equation true is -9/5. If we look at number 2, complete the given table for the equation 2x plus y equals 7. If we look at the table, they've given us the x values and they've given us some y values, and we have to find the missing values here. Again, we're going to use the same equation 2x plus y equals 7. So if we take 2x plus y equals 7, again, we're going to substitute, make 1, 2, 3, 4, 5 brief equations so we can find the missing coordinate. We're going to substitute x in for -1, for 2, and for 5. Then we're going to use the same equation and substitute y in for 3 and -1. I'm going to see if I can use this space here. If we have 2 times -1 plus y equals 7, solving for y, this becomes -2 plus y equals 7. I'm going to add 2 to both sides. I'm like skipping a step for the sake of space. So maybe I'll just add 2 right now to both sides. So we have y equals 9, because this -2 and +2 canceled, and 7 plus 2 is 9. So when x is -1, y is 9. Using the same equation, we're going to let x be 2. So we have 2 times 2 plus y equals 7. Again, our objective is that we're solving for y. So we have 4 plus y equals 7. And if we subtract 4 from both sides of this equation, solving a basic linear equation, y equals 3. So when x is 2, y is going to equal 3. Again, they give us 5 for x. I'm just going to change color for contrast here. Again, keeping the same equation, 2x plus y equals 7. This time y is 5. Excuse me, x is 5. So we're substituting here. Two times 5 plus y equals 7. 2 times 5 is 10 plus y equals 7. We're subtracting 10 from both sides. Subtracting 10 from both sides. So we have y equals -3 because 7 minus 3 is -3. So when x is 5, y is -3. So here the author has given us something else to think about here. They gave us x, y is 3 here. I'm not going to do the algebra for here because if y is 3 here, then we should automatically get the solution to be 2. And I'm going to leave that algebra for you to substitute y, 3 in for y, and making sure that you can go through the algebra to get 2. But these solutions right here should be exactly the same. I'm going to leave that algebra to you. If we look at the last coordinate, here they gave us y is -1. So we're going to use, again, the same equation, but now we're going to put -1 in here for y. So we have the equation 2x plus 7, 2x plus y equals 7. And this time we are going to use y for -1 and solve for x. So we have 2x minus 1 equals 7. We're going to add 1 to both sides. This is the step that I kind of skip sometimes because you can do it in your head. -1, +1 cancels. We have 2x equals 8. Solving for the variable and dividing by the coefficient 2. So x equals 4. So when the table y is -1, x is 4. And we have completed the table of values. If we look at number 3, complete the table of values for this equation y plus 4 equals 0. You notice that there's no x value here. There's no x value here. They give us the x value here. And the hint here is that you have to take this and solve for y. So if we take y plus 4 to equal 0, if we solve for y, that means that we're just simply subtracting 4 from each side. This cancels, so y equals -4. And y equals -4 is always going to be constant. So no matter what the value of x is, y is always going to be constant, which is going to be -4. So all the solutions here is going to be -4. And when y is constant, it's going to be, when we draw it, and if we were to plot this, this is going to be a horizontal line. And we are not at that, we won't graph it right now, but I want you to kind of start putting the pieces together, is that when y is constant, the look of the graph is going to be a horizontal line. So you can put that in your, put that in your notes, that when y is constant, the graph is going to be a horizontal line. Section 3.1.3 is plotting ordered pairs. plot and order pairs, before we get started, let's kind of look at a framework here. Let's look at a framework here. One thing you want to know when you look at this coordinate system, this is called a coordinate system. It has two axes. The x-axis, which is horizontal. This is the x-axis. This is the y-axis, is the vertical axis. And this coordinate system is divided into 4 quadrants. Counterclockwise, quadrant 1, to the left, quadrant 2, quadrant 3, quadrant 4. The x and the y-axis intersect here at the origin. This point right here is called the origin. The point at the origin is the ordered pair 0, 0, because that's where x is 0 and that's where y is 0. So this origin has the ordered pair 0, 0. The x and y coordinates are like the number line. You go to the right, these numbers are positive. You go to the left, they're negative. If you go up, these are positive numbers. If you go down, this is negative. And you can also just put some arrows at the end of here because you want to make sure that they go in infinite direction. So when we plot a point, it's in a plane. So each point has an ordered pair. So this point right here has an ordered pair of 3, 2, because the x coordinate is 3 and the y coordinate is y, and the y coordinate is 2. So when we plot this point, you start in the origin, and you go 3 units to the right and go 2 units up on the y-axis. This is the point 3, 2. So you have to think about the framework as we are plotting ordered pairs, and note that one point has 2 coordinates, an x coordinate and a y coordinate. To put this framework in, into practice, we're going to use the illustrations here. We're going to use the ordered pairs to identify each point on the given coordinate plane. State the quadrant or the axis where each lies. So we have these points here, point B, C, D, E, F, and G. Point D was left off, so I just kind of added it down here at the middle. So basically, we are going to identify the coordinate, identify each point, state the quadrant or the axis that it's on. So if we start with A here, this is the origin. The x-axis coordinate is -6. The y coordinate is -4. The coordinates for A is -6, -4. -6, -4 is in the first, second, third quadrant. Point B. Point B is on the x-axis. So you know that one of the coordinates, that the y coordinate is going to be 0. This is, again, something you can put in your toolbox. If it's on the x-axis, the y coordinate is going to be 0. Start here in the origin, the coordinate is 2, 3, 4, 5. The y coordinate is 0. So the point 0, the coordinate for the x is 5. Coordinate for the y is 0. And it's on the x-axis. It's on the x-axis. Point C, getting started or from the X value, you're going to go over -3, and the Y is going to be 2. So this is, again, going in the negative direction, 3, 2. Because remember, each point has 2 points, an X point and a Y. It tells the location of the X is -3 and the Y is 2. And this is in quadrant 1, 2. Point E is on the X-axis. You're going to go to the right 5, because on the X-axis 5, and on the Y-axis, you're going up 6 units. So the ordered pair for this point E is 5, 6. 5, 6 is in quadrant 1. Point F, again, the X coordinate is going to be 3. The Y coordinate is going to be -4. So this is 3, and then you're going to go down -4. So the coordinates here for F is going to be 3, -4, and it is in the 4th quadrant. Remember, the quadrants are counterclockwise. This is quadrant 1, 2, 3, 4. If we look at point G, G is on the y-axis. On the y-axis, so you know that the x coordinate is on the y-axis. You know the x coordinate is going to be 0. So from the origin, we're going to go down 1, 2. This is 3, so this is like 2.5. So G, the y coordinate is -2.5 because you're going in the negative direction. The y coordinate is, excuse me, oops. The x coordinate is 0. It's 0 because when you go down here, you in the ordered pair, you always indicate the x coordinate first. So the x coordinate right here is 0, and the y coordinate is -2.5. And that line is on the y-axis. The y-axis. If we look at point D here, the x coordinate is 4, and the y coordinate is 3. So point D is the x coordinate is 4, the y coordinate is 3, and it's in quadrant 1. It gives you a nice overview of how to plot points. This exercise is just to plot the ordered pairs. So you were given the ordered pairs and to determine given a point to determine the ordered pairs, and now you're given the ordered pairs and plot the point. And again, plot the ordered pairs and determine which quadrant or which axis does the point lie. So let's plot these. You can pause for a moment and plot them and then look at the solutions afterwards. The point 3, -2. Again, just to reiterate, all the x values is the first coordinate, and all the y values are the second coordinate. So, and it's consistent throughout the entire chapter. I just want to continue to emphasize that the first coordinate is x, and the y coordinates are, and the second coordinates are y. So let's plot the points. Negative A is 3, 2. Again, starting here in the origin. So you go to the x, 1, 2, 3 units, And then you're going to go down 1, 2 on the Y. This is the point right here, point A. And it lies in quadrant 4. 2, 4. Starting at the origin, you're going to the right 2. You're going up 1, 2, 3, 4. This is the point in the plane that represents the ordered pair 2, 4, and that's point B. Point B is in quadrant 1. -2, 3. Starting in the origin, on the x-axis, we're going to the left 1, 2. The y is 3. We're going up 1, 2, 3. This point represents C. C is in quadrant 2. -3, -2. Starting at the origin again, you're going to the left on the x-axis, -3 units, and then you're going down 2 units. This point right here represents the point D, and it's in quadrant 3. Again, remember the quadrants are counterclockwise. This is 1, 2, 3, and 4. And the quadrants are written in Roman numerals. If we look at E and F, you notice that they have zeros in there. So you know that this is going to be on one of the axes. The X value is 5, Y is 0. So in the ordered pair, we're going over 1, 2, 3, 4, 5, 0. This is the point E, and it's on the x-axis. 0, 5. 0 is x. On the y value is 5. We're going to go up 1, 2, 3, 4, 5. This point right here is the point F, and it's on the y-axis. And again, just a point of note that if 0 is one of the ordered pairs, you know that it's going to be on one of the axes. If we look at this, the next 2 exercises, 3 is without plotting the points, determine the quadrant. And determine, number 4 is determine whether the following points lie on the x-axis, y-axis, or neither. So it's just an exercise so you can visualize where the points are without even plotting them. I will just draw a coordinate plane over here just so you can kind of have it for reference here. Again, the horizontal lines are X, this is Y. The quadrants, this is quadrant 1, 2, 3, and 4. Without plotting, determine the quadrant the point lies. -4, 3. So the X value is negative and the Y value is positive. So the X value is negative here and the Y value is positive. So this is going to be in quadrant 2. 3, -3. So here the X value is positive and the Y value is negative. This is going to be in quadrant 4. -4, -3. So when both the X and the Y values are negative, this is going to be -4, -3. It's going to be in quadrant 3. That's quadrant 3. 4, 3. Both numbers are positive. So both numbers are positive here. 4, 3. Both numbers are positive in quadrant 1. Number 4, determine whether the following pair lie on the x-axis, the y-axis, or neither. So really, we know that it's only on the axis if there's a 0 in the ordered pair. So for number C, you know this is neither because it doesn't have 0 in the ordered pair. And F is neither, N-E-I-T-T-R. Because again, it's only on the X and Y axis if there's a 0 in the ordered pair or the pair. So determine whether it lies on the x-axis or y-axis. So you have 4, 0. So you can kind of visualize it here, 4, 0. If we were to plot this point, we would go to the right 1, 2, 3, 4 units. And since y is 0, this will be on the x-axis. So that means that this is 4, 0 is on the x-axis. And for that matter, anything where the y is 0 is on the x-axis. So if we just look down the numbers here, -5, 0, this is also going to be on the x-axis. Because you can kind of visualize it here, x is going to be -5 and 0 is going to be here. Looking at the point 0, 3, so 0, 3 is going to be on the y-axis. And again, even 0, -2, 0, -2 is still going to be on the y-axis. Okay, you can pause and redo those if you like, just for some additional practice. This last section here, identifying the relationship between the coordinates and the ordered pair. For each linear equation, two variables always produce equal differences in the y values for every equal differences in the x value. So this exercise, I'm just going to go through this and I'm going to plot the points and give you the relationship. Students will not be tested on this, but I wanted to go through it as part of an exercise so you can start understanding the relationships when we start graphing lines. So in each one of these, I'm going to plot the points. I'm going to draw the line and then determine the relationship. Plotting the points to see what the line is going to look like. These are all straight lines because they're linear equations. We plot the point 1, 4. So let's just see what the line is going to look like. This is 1, 1, 2, 3, 4. This is the first point. 2, 5. Again, starting in the origin, going to the right 2, going up 5. 3, 6. Going to the right 1, 2, 3, up 4, 5, 6. This is another point. So these are the 3 points that form a straight line. This is what the line looks like. So let's look at the relationship. All the y values are 4, 5, and 6. So if we just look at the y values, 4, 5, and 6, that's the output. And the x values are 1, 2, and 3. So we can determine the relationship here to see what this linear equation looks like. How do you go from 1 to 4? Well, if you add 3, if you add 3 to 1, you get 4. If you add 3 to 2, you get 5. And if you have 3 to 3, you get 6. So the linear equation in this relationship is y equals x plus 3. Again, now, as a student, you will not be tested on relations between your x and y, but I wanted to go through the process so you can, as we start working with graphing lines, and I'm only going to do 1 and 3. I'll leave 2 and 4 for you to exercise, and the answers are in the back of the book. Again, I'm going to plot the points first. X is 1, 4, so the point 1, 1, 2, 3, 4 is here. 2, 8. 2, we're going up here to 8. This is the point 2, 8. Negative 2, negative 8. Starting at the origin, negative 2, negative 8 is here. So the line for number 3 looks like this. It's supposed to be a straight line. I don't have a straight edge, but it should be a straight line. And if we try to turn the relationship here, the y values are 4, 8, and negative 8. And the x values are 1, 2, and negative 2. So what relationship, if we look at this, can we see that we go from 1 to 4, from 2 to 8, and negative 3, oh, excuse me, this y should be 2. I'm sorry, this should be negative 2, not negative 3. Negative 2. And sometimes you just have to look at it and study it. You may notice that if you multiply this by 4, if you multiply 1 by 4, you get 4. If you multiply 2 by 4, you get 8. If you multiply negative 2 by 4, you get negative 8. So the linear equation that matches this line in ordered pairs is y equals 4 times x. And again, now you won't be tested on this, but I want to go through the exercise so you can see the relationship between the variables x and y. So that concludes section 3.1.